Hey, what's happening, guys? It's Wednesday, 2 days away from my surgery. So I present you with the last save video I had for you. And, well, probably next video we'll be back to normal. That'd be my guess. Okay, let's go. What's up, guys? I have got a cool new multimeter for us to take a look at today. Look at that baby right there. That's pretty. This is the UT139S. And I don't usually say much about the feel of anything, but I love the feel of the condom they put on this. That is really nice. Look at that. Intertech. Interesting. There's a QR code. Yes, indeedy doody. So the manual that comes with it, which is a nice looking manual on the outside, which has English words which you will not find on the inside, is pure Chinese. But they did include some nice sheets with it, so you can kind of figure out what you're doing. And it did come with a card that has stuff on it. I'm going to call this a calibration certificate. Is it a calibration certificate? I don't know. Let's call it one and be happy with that. Anyway, this bad boy is a 6,000 count meter. It has a low impedance setting for doing some AC measurements, and it's pretty. It has a backlit display. I know you can't really see that too well. It's kind of dark to me. Let's see. Hold light. Ooh. Putting the light on made it even worse. So it's not the brightest of the reversed screens I've ever seen, but it is nice. Also in the package are a set of leads. They're labeled Unity, Cat 4 600 volt, Cat 3 1000 volt, and 10 amp, and that is highly questionable. And you also get a K-type thermocouple. So let's get out our multimeter testing stuff. And the leads. We'll have a go. What do you say? I'm excited. I like Unity meters. I do find them to be a reasonable cost with, you know, they've obviously taken steps to save themselves as much money as possible, but not as bad as some others. Like I said, they're reasonable. Alright, so let's start off with resistance, which you probably can't even see at all. Let's see if I can get in there and make that any better somehow. Trust me, it looks okay on the desk. It's just not showing up that well here. I always say we start low. We'll go with 2.2 ohms. Okay. I'm not sure why we're kind of bouncing all over there. Let's go a little higher. Well, a little higher. Let's go 1K. Okay. 10K. Okay. And 1 meg. Alright, I don't know why that's reading the low range so badly. That doesn't make a lot of sense. 2.2, 2.4. Yeah, it's close enough now. I don't know why I didn't like it before. Alright, so she does alright there. Let's function. Our continuity test. Yeah. It's the probes, trust me, it's not the meter. And let's go diodes. Get out my diode testing equipment here. Alright, the first one we're going to check is a Schottky diode, which should give us a reading, 0.2 to 0.3. Okay. Next is a high-speed diode, which should read like a silicone diode, somewhere in, 0.49 to 0.6. Okay. Then a standard silicon diode, which should read between 0.5 and 0.7. If I actually get the thing on there. There we go. Alright. What else are diodes? Well, LEDs are diodes. Let's test some LEDs. Now, depending on the output current here, it may not light all of these LEDs, but it should show the forward voltage. Like, for instance, the blue and the ultraviolet are going to be the highest forward voltage. So if it's not outputting, say, at least 2.8 volts, we're probably not going to get them to light, but we should still get a reading. Alright. Put this up here where you guys can kind of see. Try the red. It is lit. I know you might not be able to see that, but it is lit at 1.787. Yellow, also lit, 1.832. The green, very brightly lit, 2.031. The blue, dimly lit at 2.49. And the purple UV is definitely lit at 2.58. So excellent, excellent, excellent. Alright, next up, let's go with capacitance. We've got 1200. Yeah, 1200 microfarad, 100 microfarad, 10 microfarads. Then we got some smaller ones. So let me just discharge these guys first. We'll start small and go up. So this should be around 10 microfarad. Okay, reading 11, that's close enough. Next up is 100. $99.13, very nice. And 1200. $12.70, very good. Let's go super small. This is a 22. $22 puffs. Hello. Doesn't like that one. How about 224? Reading 206. 104. 89.25. Okay. So it won't read the super small, but a lot of them won't. That's alright. That's not a big deal at all. Let me get set up for some voltage tests. Alright, let's start low. 2.5 volts. Oh, Paul, what are you doing? Yeah, I had that right. 2.5 volts. Well, put it in the voltage then, Paul. What are you doing? Maybe if I turn off these, see if that makes it any better. Yeah, I think you can see it better that way. 2.503. Good. Go up to 5 volts. 5.008. Very nice. 7.5. 7.49. Very nice. And finally 10 volts. Looking good. Alright, let's go with some AC voltage. And you'll notice that says LPF. That is a low pass filter. Should be about 123.5 volts for today's flavor. Oh, it's a little low. 121.8. Alright. Now you notice we have this Hertz button here so I can get the frequency. 60 Hertz, that's what I would expect. And the duty cycle should be 50%. Right on the nose. I'm going to unplug these. And then we can go down here to our low impedance setting. And we can test that as well. Yeah. Now, generally, the impedance of a multimeter is around 10 mega ohms. When we do this here, I think we're getting down around, well, hell, let's measure it. So for this, I'm bringing in my super cheapo peak meter, which has a surprisingly good resistance range on it. Just because something's cheap don't mean it doesn't work. Yeah, 3K is our standard reading there. Okay. So when you go into the regular AC voltage range, we're looking at, look at that, 11.1, 11 mega ohms. So that's quite a difference. Won't get into it today why you want to use that, but it's generally used for power line type stuff. You can also use it in motor testing. You know, basically heavy duty stuff. Not particularly useful in electronics as itself. It's more of an electrical thing. So that's kind of a neat thing that it's on this meter, because you know we've got microamps, we've got temperature, so it's kind of a combination of an electrical and an electronics meter, which I find very nice and refreshing. All right, so we did voltage, we did resistance. It's got the special millivolt range. Let's go down and take a look at that. Okay, we're checking out the millivolt range here, and I'm as low as I can go, and it's showing 0.5 millivolts. So if we crank it up a little bit, there is 109 millivolts, 177 millivolts, 264 millivolts. That is very nice for low voltage. And you'll notice here the bar graph seems to be rather close in operation to the main display. So that is really nice. Now this is a 6,000 count meter. So if we take it up to what? A little over 600 millivolts. Boom. We get an out of range or overload or open loop or whatever that is. And you can see that the bar graph shows that little arrow right at the end. So, very, very cool. Speaking of cool, what do you say we take a look at the temperature settings? It comes with a K-type thermocouple, which I have frozen inside this mug. Plug her in here. Wow. Pretty chilly in that mug, isn't it? Yep, broke the mug. I thought the water would just rise up. I didn't think it would be that much force that it would expand sideways as well. Then if I press, what is it, the select button, there we go, we get Fahrenheit, 13 degrees. Very nice. So far, everything I'm seeing in this meter is just well done. So I guess what we need to take a look at next is how it's actually built. What do you say? Should we open her up? Absolutely. Alright. Let's see what it's going to take to get the raincoat off of it. This is a really nice protective rubber holster. Feels like silicone, but you know, I'm no chemist. So it can be made from almost anything. I wouldn't know any better. Come on. That screw's really must be long. There we go. Yep. Oops. Well, it is a non-captive screw. I personally prefer captive screws, but you know, you get what you get. Put that guy back down in there. Or not. Okay, we get 2 screws here, and you can see a fuse there already. These feel like self-tappers going into plastic. Alright, what am I missing? Those are loose. Is there a screw hidden under this somewhere? There's my spudger. One moment. I got the bottom loose, no trouble, but the top doesn't seem to want to quite come off. So I'm guessing there's something hidden under this Intertech label, but I'm not finding it. Come on. That's interesting. There's all kind of writing there. Give me a minute. There's no other screw. There's only 2 screws holding it down. And this says, caution to prevent damage or injury. Install quick acting fuses with something volt rating shown. Okay. Okay. Now we're talking. Let's get down in here. Make sure we're focused. Alright, where do we start? I'm going to start at the top. Alright, we got a big quad flat pack here. What's that say? Can you guys read that? I can't quite read it. HY 11 P14. I have to look it up for sure, but probably it looks like a microprocessor. Now this one over here, I don't know if I can get it close enough for us to read it. That's the DTA066OL. That's a classic multimeter chip. Alright, let's go back down here. So they put a lot of tech into this already. Beeper, crystal, got a couple crystals. I'm gonna smudge on this stuff here. 2 crystals. There's our beeper. There's a nice insert for that battery holder. There's our battery contacts. There's an inductor. But when we come over here, yes indeed, there's the magic. We've got 3 PTCs and 3 MOVs. We've got diode clamping. Yeah, that's nice. 600 volt, 600 milliamp fuse there. 600 volt, 10 amp fuse there. There is our current shunt. And I was right, those case screws go directly into the plastic. Now if we go back up here to the top, There is a 5-pin header there, J1, and over here is a, that's 6, yeah, it's a 6-pin header, COM1. And then there's our board information, 139E/S 120517 TAC 1, Rev 08.2. Now this is a board that I really wouldn't be too worried about. I mean, this is a multimeter I wouldn't be too worried about using on more high voltage jobs. If you look here under the fuse, we've got an anti-tracking slot there. We've got anti-tracking over here. We've got nice wide tracks. How wide are they? Those are some big tracks. Let me get, I mean, this is just an estimate, but those are, yeah, those are 5 millimeter wide, maybe 6, 5 or 6 millimeter wide tracks. Plenty of vias in them. That's coming off the 10 amp going through the fuse. Then you can see we've got the same over here for the shunt. That's a little skinnier. That's maybe about 3 or 4 millimeter wide. And you can see the solder coming through from the other side. So they have basically solder plated them to increase the current carrying capabilities. This is well designed. Yes, I like this meter. If we take a look at the case here, you can see it is got almost a ½ an inch of this inset lip here. That is that's nice. That's going to give you some protection in case, you know, something goes seriously wrong. Why are you not going in? There we go. All it took was a little brute force. Okay, so this is probably the most expensive meter we've ever reviewed on the channel. It's listing for $80. Let's check out the non-contact. There are my LCD lights. I'm going to bring it further away. Not bad. I really like it. I think this is going to become my main meter. I will put a link to this down below. I want to thank Banggood for sending this out to us free of charge. If you guys like this video, give it a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. Big thanks to you guys for watching. That's it. I'm out. Peace.